All right, so we are going to be talking about factoring trinomials in the GCF. If you guys recall, the most popular way to factor trinomials is what people call the X method. There's people who like the box method. There's a guess and check. That's my personal favorite. I prefer guessing and checking because it doesn't require so much structure. I can actually just think about stuff and wonder what works. But not everybody likes that method. So the X method is usually the best method to do, okay? But before that, we're going to talk about the GCF, okay? Because sometimes when you're factoring, it's best to figure out what do they have in common and remove it. That way you make your problems easier to do. So let's discuss the greatest common factor. Okay, that's what they call the GCF. The greatest common factor. So this is the term or terms that an expression shares. Okay, so the term or terms that an expression shares. So for example, if I were to write 2x squared plus 4x plus 8, that's three different terms. Okay, but I could ask you, do they have anything in common? In other words, is there a number that they all have in common? Right? What number could I factor out from 2, 4, and 8? A 2, right? So I can take out a 2. Could I take out a letter from all three terms? No, because the 8 doesn't have one, right? The first two terms have an x squared and an x, so that's good. But the last one doesn't. So what you do is you factor. And guys, remember, the word factor means divide. In other words, I'm dividing by 2. When you factor by 2, what you're basically saying is I'm going to divide by 2, right? So if I factor a 2 from 2x squared, what's left? Just the x, or the x squared, right? Because I didn't touch anything there. If I factor a 2 from 4, what's left? A 2, so 2x. If I factor a 2 from 8, what's left? A 4, okay? That's called factoring using the greatest common factor, okay? That is the very first thing you should always ask yourself, okay? So I'm going to write that down right here. Always. I'm going to highlight that, okay? Super important. Always try to factor the GCF first, if possible. Because if you can factor something out from your problem, it usually makes your problem so much easier to do. Okay? So if you can factor it, it makes it so much easier to do. Just to show you an example of something like this, and then we'll do some actual examples from your homework. But if I were to give you a problem that looked like this, 100x squared plus 200x plus 100, and I tell you factor it using the x method, okay? How many of you guys, just out of curiosity, how many of you guys know the x method? You guys remember the x method where you're supposed to go like that? And does that look familiar to anybody? Any show of hands? Like, yeah, okay, so there's some familiarity. So what you're supposed to do is multiply the first and the last numbers. Well, what's 100 times 100? Well, that's 10,000, right? And then you're supposed to put the term in the middle, the 200 down here. And now your job is to say, okay, what factors of 10,000 add up to 200? That's hard. Okay, how am I going to do that, right? So there's a better way to do it. Factor out your GCF, which is 100. That's what they have in common. And this is what you end up with. And this is really easy to factor. Okay? So that's why they tell you always try to see if you can remove something. If you can factor something out, factor it out, because it's only going to make your problem easier to do. Okay? So the top problem, the 100x squared plus 200x plus 100, that's a tough one to do because the numbers are so large. But if I factor out what they have in common, which is a 100, then all of a sudden, factoring x squared plus 2x plus 1 becomes manageable. Okay, very simple. All right, and we'll get to that right now. Okay, how to do that. But before we do the x method, in case you don't remember it, we'll get to it. I want to go over these problems. Okay, you have 4 problems that are just factor the common factor out of the expression. In other words, what do they have in common? Factor it out. Okay, so let's work on question 2, and then we're going to work on question 5, and then we'll go to the x method, and we'll talk about that. So look at question number 2. What does 2p squared plus 10, so 2p squared plus 10, what do they have in common? A 2. Do they have a letter in common? No, right? Only one term has it, not the other one. So I'm going to take out a 2. What's left over if I take a 2 out from 2p squared? P squared. What's left over from the 10 if I factor out a 2? A 5. And look, it's right there. It's C. That's my factored form. Now, I'm just factoring the GCF, only whatever they have in common, okay? So that would be my answer for part C. Okay? Actually, I didn't want to do 5. Actually, 5 is fine. 4 or 5 are okay. It doesn't matter. Let's do question 4. It looks like it's going to be more difficult. I don't know if it will be, but it looks like it, so let's try it. So what can I factor out from negative 6n to the 6th? Let me write this down. Negative 6n to the 6th plus 4n cubed plus 4n. Is there a number that 6 and 4 have in common? A 2. They can all be divided by 2, right? So I'm going to put the 2 right here. Is there a letter that they all have in common? How many n's do they have in common? Just 1, right? You might say, no, they have 6. But remember, do they all have 6 n's? No, right? We're trying to figure out how many variables they all have in common. Well, they all have at least 1. So I'm going to put that right there. And then I'm going to start my parenthesis. Now, if I take out a 2n from the negative 6n to the 6th, okay, so let's worry about it in terms of numbers first. If I get negative 6 and I factor out a 2, what do I get? Negative 3, thank you. And then if I get n to the 6th and I take away one of the n's, what's left? N to the 5th, so thank you very much. So my first term would be negative 3n to the 5th. Okay, plus, now again, let's do just numbers. 4n cubed, okay? If I have the 4 and I factor out a 2, what's left over? A 2, thank you. And then if I have an n cubed and I...
This is a field trip for Jose. It's for Field of Valor and it's due by Monday.
So we said if we factor out a 2 from the 4, we get a 2. From n cubed, if I take one n out, I end up with n what? N squared, right? All right. And then plus 4, if I take out a 2, well, again, I'll get a 2. And if I have an n, 4n, right? If I have that n over there, and I factor out an n, is there still an n there? No, it's all gone. So this is the factored form. Okay, so which one would that be? I need n to the 5th, the 2n squared, that's going to be D. Okay, so this is what the greatest common factor is. Okay, you're taking out just whatever they have in common. Okay, you don't have to take everything out. Like, it's not always a letter, it's not always a number. Sometimes it might just be a letter with no number that you factor out. Sometimes it's just going to be a number without a letter. Sometimes it's both, okay? But it just depends on what the problem looks like, okay? So you have 4 of those problems you're going to be working on. We just did 2. But notice after that, it says factor completely. Okay, and they all look like this. And there are, I think, a total of 18 of these. So we'll try to do as many as we can. Let me see, how many are there here? That's 4, 8, 12, 13. So let's see if we can do 6 at least. We'll see. Okay? So let's talk about the X method. For those of you guys, if you don't remember it. So the X method for factoring. So normally you're going to be given an expression, okay? Ax squared plus bx plus c. That's what you're going to be given. Something that looks similar to that. Okay, now there are some special things that don't have 3 terms, and we'll talk about those things tomorrow. But for the most part, you're going to have 3 terms. Okay? So what you do is this. Let me write this out here. If a equals 1, okay? If a equals 1, so there's no 2x squared or anything like that. It's just an x squared. So if a equals 1, what you're going to do is you're going to create an x like this. On the top part of that x, you're going to do a times c. Okay? On the bottom part, you're going to write your b term. Okay? And your job is going to be to find some numbers here that multiply to this number. They have to multiply to whatever that number is up there. So if that number was a 10, you think, okay, what 2 numbers multiply to 10? 1 times 10, 2 times 5, right? That combination. But whatever those 2 numbers are that you get, they're going to have to add up to b, whatever b happens to be. So we'll do these examples, okay? If a equals 1, that's what it looks like. Okay, you just try to figure that out. Now, if a is not equal to 1, then the same picture basically comes out. Okay, let me just copy paste it if I can. Let's see. Let's see if I'm able to get that to work. Okay, it's going to be the same, but there's one crucial step. These numbers eventually have to be divided by a. Okay, that's the only difference. And I know this looks really confusing when you just look at it like graphically. So it's best when we work on it together. It's not that difficult to do, okay? But it doesn't look like it's easy, but it really isn't that difficult. Okay? So if a equals to 1, then don't forget to divide by a once you find your numbers that multiply to the top and add to the bottom. Then you'll divide by a at the end. Okay, so let me show you some examples for this. I'm going to zoom out real quick, okay, just so I can get a couple of examples. So let's see. Let's try number 6. So number 6, m squared plus 2m minus 8. Okay, and I want to factor this. Okay, now notice a is equal to 1, right? In front of that m squared, there's no number, so it's a 1. That means I don't have to divide by anything at the end. Okay, so here we go. On the top, I need to multiply. I'm going to kind of write it right here, okay? There's a 1 there, okay? I'm just going to write it there. You don't need to write it, but I want to do it just for you so you can see it. At the very top of the x, I'm supposed to get my a term and my c term. 1 times negative 8, and I'm going to put it right here. That's the multiplication of 1 times negative 8. Okay? On the bottom of that x, I got to get my b term. What is my b term? 2. So that goes here. Now, think of two numbers that multiply to 8 but could add or subtract to 2. 4 and negative 2. Perfect. So I'm going to put this in a different color here. Positive 4 and a negative 2. And notice I'm going to put little circles around them to basically say these are my answers. Okay? So how do I write this down? Well, here you go. The letter that we're using is an M. So I'm going to do that. Okay? And then notice how one said plus 4, so I'm going to put plus 4. The other one said minus 2, so I'm going to put minus 2. And we're done. That is the factor of m squared plus 2m minus 8. Okay? So you just got to figure out those two numbers on the sides. And if you can figure out those two numbers on the sides, that's all you need. Now, I know I didn't do this with you guys, but check it out. Positive 4 times negative 2 is a negative 8, right? So that multiplies to this number up here. They do multiply to that number. Positive 4 minus 2 is 2, which is this number right here. So as long as they multiply to the top number and add up to the bottom number, you're good. Okay? That's what you're looking for. You want them to do that. So let me check a different number, and then let's see if you guys have any questions here. But so the first ones are okay. Let's do number 9, okay, because that one's a little different. So number 9 is a negative n squared plus 2n plus 15. Go ahead.
Can the two numbers add to the bottom?
It's add or subtract. So you're basically looking at, see how I put plus 4 minus 2? So I just combine them at that point. I say positive 4 minus 2 is 2. If they were both positive, I'd add them. If they were both negative, well, I'd add the negatives, right? Whatever the symbols are, that's what I'm going to do. But they do have to sum up to that. Remember, summing or adding doesn't necessarily mean you're adding positive numbers, right? You could add negative numbers, right? So it's not, they don't always have to be positive. Let me make sure I wrote this right. Plus 15. Okay. So you guys notice how this problem has a negative in front of it? So what I'm going to do is I'm going to factor that out. That's going to be my greatest common factor, okay? The number 6 did not have a number in common. It didn't have a letter in common either. But number 8, I don't like the fact that there's a negative in the front. So I'm going to take it out, okay? So negative on the inside will be n squared minus 2n minus 15. Okay? So I just took out the GCF right now, the greatest common factor. Now, I only want to factor this part right here. Okay? I don't care about that negative. That negative is just going to trail with the problem. Okay? Don't forget to put the negative in once you get your answer. But I'm only going to worry about the stuff inside the parentheses. So, let's do the X method for the stuff inside the parenthesis. So what number should I put up on top? Well, multiply them, so that gives me negative 15, right? 1 times negative 15 is negative 15. What number do I put on the bottom? Negative 2. There we go. All right, now if you're thinking, no, positive 2. There's a positive 2 there. Yes, it was positive 2 before I factored it. Then it became a negative, right? So I had to make sure I put that in there. Now, two numbers that multiply to 15, but that would add or subtract to a 2. 3 and negative 5. So positive 3, you're saying, and a negative 5. Let me keep this green. Positive 3 and a negative 5. So let's see. Positive 3 times negative 5 is negative 15, so that's good. Positive 3 minus 5 is a negative 2, so that's good as well. So we have the right numbers. So all I have to do now is create my two parentheses. Okay, don't forget your negative in the front. Okay, very important. Remember, the negative has to basically carry all the way through, right? So don't forget it. It's easy to forget, so don't forget it. Now the variable I'm using is an n, so I'm going to write n right there. And then according to my answer, I put plus 3 and a minus 5, so plus 3 minus 5. And that's my solution to this factor. You guys have any questions on this so far? We're going to do more, okay? We're not just doing 2 and then, okay, we're done. Like we'll do, if I can do 4 more for you guys. Again, these are homework problems. I apologize if the lesson goes kind of long. The lesson's officially done. We're just kind of working on homework together now, right? So if you don't mind, I kind of want to do some more problems with you guys so you can see many of them. And you're still going to have a lot to do for homework anyway, but we'll try to knock out as many as possible. Any questions on this? All right, so let's check out, let's see. I think we're good with 10 and 11. Let's go to 12. So 12 is 3x squared plus 13x plus 4. So number 12, 3x squared plus 13x plus 4. And I'm going to factor this. Now notice, my a term is no longer a 1. It is a positive 3. Which means once I find my answers, you know those numbers that I put in green and I circled them? Once I find those answers, I need to divide by 3. Okay? I got to divide by 3. And then we do something that's called bottoms up, which is just a way to simplify your answer. Okay? So here we go. We're going to still do it the way we normally do it. Now, first off, can I factor anything from these? Do they have a number in common or do they have a letter in common? No, right? They don't have any numbers in common. Sure, 2 of them have x's, but not all 3. So I can't do anything. So I'm just going to have to start. On the top, I'm going to get my 3 times 4. That's a 12. On the bottom, I'm going to put my 13. Okay? What 2 numbers multiply to 12 but add up to 13 or subtract to 13? 12 and 1. Good. 12. Now positive for both, right? Positive 12 times positive 1 is 12. Positive 12 plus 1 is 13. So it looks good. So I'd say, great, I'm done. The problem is if you go straight to here, by the way, don't write this down, okay? Please don't write this down. If you do this, you're wrong. Okay? Why are you wrong? Again, don't write this down. Check out what happens when I distribute all of this. This is my result when I distribute it. Does this resemble the original question? No. It's not right. Did I do something wrong? Well, not entirely. You just didn't finish the problem. Okay? If your a term is not a 1, which ours is not, ours is a 3, you need to divide by that number. The green stuff that I have right there, you have to divide by 3. So 12 divided by 3, that's a positive 4. Now I'll circle it. 1 divided by 3, I can't do it, so I'm just going to circle it. Go ahead, Max. The 12. Oh, you mean when I expanded? Or are you talking about this number here? Oh, okay. For the top number, you multiply this number times that number. Yeah, the 3 times 4. Remember the definition says A times C on the top. So A is your first number and C is your last number. So yeah, the question of where did I get the top 12? I just multiplied 3 times 4. All right, so again, I circled the 1/3 because that doesn't simplify, so just leave it alone. Now you're going to do what you did before. You're going to put 2 parentheses. I'm going to put an X on both of them. One of them I'm going to put plus 4. The other one I'm going to put plus 1/3. But you're not supposed to have fractions. So this is what I usually tell people. Bottoms up means get this bottom number, move it up to the front of the X. So your answer is going to be X plus 4 times 3X plus 1. Now, you don't have to write this next part, but let me just show you. If I were to distribute everything back, I would get 3x squared plus 13x plus 4. Is that the same thing as that? Yeah, right? It's identical. So that means I did it right. Okay? So you can always check your work if you want to. Just distribute, make sure that you got the right answer. So remember, you only have to divide if your A term is not a 1. Sorry? Sure. Do you want to see the previous problem or?
I want to see the example, the A times C.
Oh, okay. Let me move back up here. While you're writing that down, let me just look to see what other problem I want to try out here. So we'll try 16. Let me just write it down, and I'll get to what we need. So 4x squared plus 18x minus 10. Are you good, Vince?
Yeah, thank you.
All right, awesome. Okay, so probably the last one we're gonna do. Okay, so like I told you guys before, anytime you factor, the very first thing you want to check is, can you take anything out that they have in common? So is there a number that all of these numbers here have in common? Is there something that can divide them all? A 2, right? Do they have a letter in common? No, right? So only a 2. So what I'm going to do is I'm going to take out a 2. And then I'm going to factor it. So 4x squared, if I divide it by 2, I get 2x squared. If I factor out a 2, I mean. If I factor out a 2 from 18, I get 9x. And if I factor out a 2 from 10, I get a 5. Okay? So we want to do that first. Now, we're only going to pay attention to this piece for now, but do not forget that there is a 2 right there on the outside that has to be in your answer. Okay? Don't forget about that too. But let's just do the X method on the stuff that I have that squiggly line under. So here we go. So A times C, that's 2 times negative 5. That's going to be negative 10. And my B term is positive 9. So just a 9 right here. Okay? So I have to think of 2 numbers that multiply to 10 that can give me a 9. Negative 1 and positive 10. Let's see. Yes, that works. Now, I can either circle those answers and say I'm done, or I got to ask myself, is A a 1? So if I look at the squiggly line, is my a term a 1? This part right here? No, it's a 2. So what am I supposed to do? If a is not 1, what do I do with that 2? I got to divide, right? So let's divide by that 2. Notice I can't simplify negative half, so I'm just going to circle it, okay? But 10 over 2, that's a 5, so plus 5. Now we're done. Now we just got to write it out, but if we have any fractions, we got to do the bottom part and move it up, right? The bottom's up, so here we go. I have a 2 on the outside. Don't forget about that 2. Okay, that one that I highlighted in yellow. And then this is going to be x minus half x plus 5. Okay, get that half part, the denominator. Sorry, I wanted to use a different color here. And move it to the front. Okay, move it up to the front. So your final answer is 2 times 2x minus 1 times x plus 5. Okay, that's the solution you're going to be looking for. Now on your homework, I think they gave you 5 problems like these, okay? Where you could factor stuff out first, all right? So you can factor out a certain number or a certain letter out first, and then you do your x method. I've done one of them. There's 4 more, but we have done some other ones like it too. But there are 4 more that they gave you. But they're all similar to this stuff. Just factor out whatever numbers they have in common and then just do the x method. It's not much tougher than what's up here. Okay? They're going to give you some where a is equal to 1, where you don't have to do any division. Just factor out. And like I said, they're going to give you some in the very beginning where all they're going to ask you is take out the greatest common factor or factor out the common factor. Okay? So look for that stuff when you're doing the homework. Let me give you that assignment right now. And I know we don't have a lot of time to do it, but if you have questions, just ask tomorrow or later today. It's up to you.